So now we've got a little bit more complicated function here. Again, we're going to look at the restrictions. Well, we've got an x in the denominator here, an x in the denominator here, and a 1 minus x in the denominator here. So the restrictions would be x cannot equal 0 or 1. Okay, because we don't want that to be 0 in the denominator there. Alright, so we will take this function and we, again, just like over here in part C, we're going to multiply through by the common denominator, which hopefully after seeing the first, or part C, we'll see that the common denominator would be x times 1 minus x. So we'll multiply through by that. So what I haven't really shown in any of the cases yet is that when we do something to one side of an equation, we do it to the other side of the equation, or basically we're doing the same thing to everything in the equation. So we're actually multiplying the entire equation by this common denominator, and that would have been the same case in all the other examples. And then we just expand that in, so we end up getting x quantity and 1 minus x times 1 over x, and that equals x quantity 1 minus x times 2 over x, and on it will go. Okay, and then we'll just cross out the things that will cancel. So x divided by x gives 1, x divided by x just gives us 1, nothing cancels there, and 1 minus x divided by 1 minus x gives us 1 again. And then we can simplify here, so we get 1 minus x equals 2 times 1 minus x, and then here the whole thing stays, so x times 1 minus x, sorry, not equals, plus x. And then we'll just expand this and do some simplification. So 1 minus x equals 2 minus 2x plus x minus x squared plus x. And so we've got a negative 2x here, a positive x and positive x, so all of those just disappear. They cancel each other out here. So this is very exciting. And we'll bring everything over to one side. So we'll add x squared to both sides. We get x squared here. Leave that negative x. Subtract 2 from both sides. We get negative 1 equals 0. And so then we'll do, if we try to factor that, we can realize fairly quickly that we cannot. So we'll use quadratic formula. So we will solve this. So the negative b would give us 1 plus or minus negative b squared, which is again just 1, minus 4 times a times c. Let's square root of that. And then all over 2a, which is just 2 then. So we get 1 plus or minus 1 plus 4 over 2. So x equals 1 plus root 5 over 2, or x equals 1 minus root 5 over 2. And then if we divide that, and the reason why I'm going to divide, usually we just leave these as exact values like they are here, but I'm just going to divide them because when we put this equation into Desmos, which I'd like you to do, put in y equals x squared minus x minus 1 into Desmos and see where the zeros are, we can see that when we just to verify the decimal values of them. and the decimal value of this is 1.618, which Desmos will probably round to 2 decimal places, and this is negative 0.618. Okay, so if you could please graph this in Desmos, x squared minus x minus 1, or y equals that, and then also graph, separately graph 1 over x, y equals 1 over x, and then y equals 2 over x plus 1 over 1 minus x, to see that the solution, or the intersection point, the x value of that intersection point of this, these two functions together, will be the same as the zeros of this quadratic, which you'll see will be these values down here. Okay, so we just want to bring in some algebra with the rational functions. Okay, so let's move along to the next example on the next page.